Okay, good morning to everyone. So, shout out to all my students and thank you for subscribing my YouTube channel. Okay, so for today's lesson, I prepare 4 questions in mathematics. So this is about calculus, guys. So if you have knowledge about derivative, so for sure you can relate to this question. Okay, so let's start. Question number 21. The surface area of a sphere is decreasing at the rate of 4 cm squared per second. Find the rate at which radius of the sphere is changing with r equals 6 cm. Okay, so first thing to know, class, is the formula of the surface area of a sphere. So we have S is equals to 4 pi r squared. So this is the formula of the surface area of a sphere. And then next is we will apply here the derivative, because why we need to apply the derivative? Because this question is something to do about the rate of change. Okay, so that's the main reason. Now, so in the first sentence, we have the surface area of a sphere is decreasing at a rate of 4 cm squared per second. We can write it as ds over dt is equals to 4 cm squared per second. So when we say ds over dt, so we are referring to the difference of the surface area over the difference of the sine. Okay? So it's equals to 4 cm squared per second. And then, using this formula, ds over dt is equals to s prime times dr over dt. So dr, because we are going to find the rate at which radius of the sphere r is changing with r equals 6 cm. Okay, s prime is the derivative of this formula, which is 4 pi r squared. Okay, now let's do this substitution. Okay, so for ds over dt, we have 4 cm squared per second, so which is equals to 4. So it's equals to 4. Then it's equals to the derivative of this is 8 pi r. So where did we get 8? We just multiply 4 times the base and the exponent. Okay, so that is the application of derivative. And then times dr over dt. Okay, now we have this equation. So we will replace now with when r equals 6 cm. So substitute it here. So it will become now 4 is equals to 8 pi r is 6. Okay, 6 then times dr over dt. So divide both sides by 8 pi times 6, 8 pi times 6. So cancel this. Okay, so we have now dr over dt is equals to 4 over 8 times 6 is equals to 48. Okay, so 48 pi. Then 4 over 48, the lowest term is equals to 1 over 12 pi. Okay, so therefore the answer in number 1 is equals to 1 over 12 pi cm per second. So this is answer in number 1. Find the rate at which radius of the sphere r is changing with r equals 6 cm. So that is the answer. 1 over 12 pi cm per second. Okay, guys? So let's proceed to question number 20. Given y equals 4x cubed minus 3x squared plus 2, find the approximate decrease in y when x decreases from 1 to 0.8. Okay, so the given function here, y equals 4x cubed minus 3x squared plus 2. Now, so if we are going to apply the derivative here, So we have dy over dx. So it's equals to change in y over change in x. Okay? So it can be written as dy over dx is equals to change in y over, so the change in x is from 1 to 0.8, which is equals to negative 2. Negative 0.2. Okay? Then, if you will get the derivative of this function, so change in y over negative 0.2 is equals to, okay, we will get the derivative of this. So they have an idea on how to get the derivative of this. So multiply the base and the exponent. So 4 times 3 equals 12. Then x, you will subtract 1 here, 3 minus 1 equals 2. Then minus, multiply 3 times 2, the answer is 6. So right here, 6. Then subtract 2 minus 1 equals 1. So exponent is 1. Okay, then cross multiplication in order to find the change in y. So find the approximate decrease in y. So it's equals to change in y equals negative 0.2 times 12 times the value of x from 1. So we will use 1. Then raised to 2 minus 6 times 1. Okay. Then simplifying, if we will simplify, 1 squared is 1 times 12, 12. 6 times 1, 6. 12 minus 6 equals to 6. So 6 times negative 0.2. So change in y is equals to negative 1.2. Okay, so this is the answer. So therefore, the answer here in question number 22, we have y decreases by negative 1.2. So this is now the final answer. Okay? So let's proceed to question number 23. Given that the object is at position x sub 1 equals 40 cm at t sub 1 equals 4 seconds, then and x sub 2 equals 30 cm at t sub 2 equals 6 seconds. The question now, find the average velocity. So to find the average velocity, we have average velocity is equals to, so we will use here the formula x sub 2 minus x sub 1 over t sub 2 minus t sub 1. Everything is given already. Okay? So substitution, x sub 2 we have 30 minus 40 over t sub 2 is 6 minus 4. Okay, 30 minus 40 is negative 10 over 6 minus 4 is 2. So negative 10 divided by 2 equals negative 5. So we have negative 5 cm per second. So the answer here in question number 23, find the average velocity. So the average velocity is equals to negative 5 cm per second. Okay. So next, we have the question number 24. The position of a particle along a line in t seconds is given in meters by x equals 40 squared plus 60 plus 1. So the given function is this, x equals 40 squared plus 60 plus 1. So the question now is find the velocity of the particle at t equals 2 seconds. Okay? So here, velocity, so we have the velocity at t equals 2 seconds. Okay, at t equals 2 seconds. Then is dx over dt at 2 seconds also. Okay, so 2s. Okay, now what will be the solution? So we have dx over dt is equals to, get the derivative of this, 4 times 2 equals 8, so 8t. Then the exponent of this is 1, 1 times 6 equals 6, so plus 6. Then is equals to, t equals 2, so substitute 2 here, so 8 times 2 plus 6 is equals to, 8 times 2 is 16, 16 plus 6 is 22. So we have now 22 meters per second. So this is now the answer for number 24. So the answer here will be 22 meters per second. Okay, so that is the velocity. Find the velocity of the particle at t equals 2 seconds. Okay, guys, I hope you learned something about these questions, calculus. So always subscribe in my channel. So keep in touch, guys. Okay, so have a nice day to everyone. Bye-bye.